Within the Milky Way galaxy resides over 100 billion stars, as well as spectacular nebulae that act as the furnaces of life throughout the cosmos. Perhaps one of the most interesting things, however, is that in this one section of the galaxy known as the Orion Arm, in one solar system resides a planet which we know as Earth, and is the only place we know of to harbour life as we know it. The solar system in which humanity lives is made up of 8 recognised planets, those being Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We will be taking a look at each one individually, discussing their formation, properties, and other pieces of historical information. At the centre of the solar system is of course the Sun, which will also be discussed. The first thing we will be taking a look at, however, is comets. These cosmic snowballs have a nucleus which is commonly made up of supercold methane, ammonia, carbon dioxide and water, of which all are in ice form. The comets themselves also contain other materials such as rocks and debris from around the solar system which make up the outer portions. Their sizes vary greatly from just a few meters to a few kilometers in width. As comets approach the Sun, they begin to lose mass due to a process known as sublimation. Eventually, these comets will break apart from being so small and from moving at such high speeds. Probably the most famous and well-known comet is Halley's Comet. It has an orbital period of 76 years and will not be at close approach to the Sun for another 38 years. Astronomers have linked the comet's appearances to observations dating back over 2,000 years. The comet was last seen in 1986 and will return in 2061. At the centre of the solar system is the Sun, which provides light and heat to everything around it. Formed approximately 4.6 billion years ago from a collapsed nebula, it is a G25 class star. This means it is the second hottest star in the G classification and is part of the main sequence of stars. It has a surface temperature of around 5,800 Kelvin. Its formation began when a solar nebula began to collapse in on itself under the force produced by gravity. And as this happened, the material from the collapsing nebula began to spin faster and faster, forming a disc-like shape. Majority of the planetary nebula's material, 99.8%, was pulled toward the centre of the disk, which resulted in the formation of the Sun. The remaining material makes up everything else in the solar system, from the asteroids and comets to the gas giants and rocky planets. The Sun primarily consists of hydrogen and helium, of which the former is fused into helium by nuclear fusion within the Sun's core. Temperatures reach around 15 million Kelvin within the core, and this combined with incredibly large pressures allow the fusion process to occur. Currently, our star is around 4.6 billion years old and has about 5 billion years left of life in it. It is expected to expand into a red giant due to the extreme radiation pressure within once the fusing of helium begins, and will engulf Mercury and Venus during the expansion, even possibly Earth. Eventually, the red giant will lose its outer layers and the Sun will become a planetary nebula. And eventually, once that has dissipated, a very small and very dense white dwarf. Mercury is a god in Roman mythology known as the messenger deity, as well as the idol of travellers. And the planet was so aptly named after him by the Romans due to the planet's rapid rotation around the Sun. The planet claims the title of the smallest in the solar system, having an average equatorial radius of 2,441 kilometers, making it 0.38 times smaller than Earth's. Mercury also has the honour to claim the fastest orbital period of a planetary object in the solar system. One year on Mercury is equivalent to 88 Earth days. However, one solar day on Mercury lasts 176 days, and the time for one rotation of the planet itself is 59 days, making it almost tidally locked to the Sun. It is estimated that Mercury formed around 4.5 billion years ago from the remnants of the solar nebula discussed in the previous section. It is made up of a central core, which may or may not be molten, a rocky mantle and a solid crust. The core makes up 42% of the planet's volume, whereas comparatively Earth's only makes up 17%. Mercury is also very dense despite its small size, being the second most dense rocky planet in the solar system, second only to Earth. Mercury is the second hottest planet in the solar system, with its sun-facing side reaching 700 Kelvin. It is also the most cratered planet in the solar system, since it does not geologically heal itself like other planets. It also lacks an atmosphere to help with the burning up of incoming meteorites. Much like Mercury, Venus gains its name from Roman mythology and is named after the goddess of love and beauty. It is the hottest planet in the solar system, rivaling even Mercury with a surface temperature of 753 Kelvin, hot enough to turn lead into liquid. Venus is also only ever so slightly smaller than that of the Earth, with an equatorial radius of 6,052 kilometers compared to Earth's 6,378 kilometers. Its density is also similar to that of the Earth and has a surface gravity of 8.8 meters per second squared, which can also be compared to Earth's 9.81 meters per second squared. Strangely, Venus rotates in the opposite direction to most other planets in the solar system, and whilst the exact cause of this rotation is not known, it is theorized it is likely due to a collision with an object of some kind. Unlike Mercury, Venus has a very thick atmosphere, with a density 92 times greater than the Earth's. The pressure felt on Venus' surface is like being deep below the ocean on Earth. Its atmosphere is made up of around 96.5% carbon dioxide. It is the carbon dioxide which traps heat within Venus and results in a runaway greenhouse effect. It is also estimated that Venus formed 4.5 billion years ago, much like Mercury and, as will be seen, the other planets in the solar system. This is once again due to the leftover material from the solar nebula. It has a central core, a rocky mantle and a solid crust. The blue marble in which all of humanity currently resides is the planet Earth. It is the third planet from the Sun and the only place to harbour life that we know of so far. The name Earth is likely to be over 1,000 years old and has its origins in Germanic wording, Earth literally meaning the ground. Once again, it is estimated to have formed 4.5 billion years ago from the remaining solar nebula material, and has a central core, rocky mantle and a solid crust. The formation of the Earth, however, could not be talked about without mentioning the first natural satellite we come across in the solar system, the Moon. In the young solar system, when planets were forming from the remnants of the solar nebula, many planetismals and protoplanets collided with one another, forming larger objects. One such object which collided with the forming Earth was estimated to be around the size of Mars. The collision between Earth and this object threw so much material up into space that it allowed the Moon to form. The Moon is the largest natural satellite compared to its host body in the solar system, and the second densest natural satellite in the solar system. Of course, this planet is home to the human race. All that we know, all of our history has come from and taken place here. 1957 was the year of the first rocket launch into space by humanity, Sputnik 1. Merely 12 years later, Neil Armstrong and Buzz Aldrin would land on the Moon, marking possibly one of the most defining moments in human history, proving that we have the capability to travel to other worlds. Despite having evolved on this planet and lived here for millions of years as a species, there is still much to discover and explore here. Space agencies across the world regularly use satellites to monitor the planet for various pieces of research and general data gathering. A very prominent and important topic is climate change, and these satellites can be used to look at our atmosphere and determine areas of high greenhouse gas emission, and steps can then be taken in an effort to reduce those emissions. Mars is another planet named after a Roman god, namely Mars, the god of war, due to the planet's reddish colour being reminiscent to that of blood. As you may have already guessed, this planet was indeed formed 4.5 billion years ago from the same material as Mercury, Venus and Earth. Mars is about half the size of Earth and also has a central core, a rocky mantle as well as a solid crust. Mars' red appearance comes from the oxidation of iron minerals within its dirt. The planet's atmosphere is made up of mostly carbon dioxide, nitrogen and argon gases, and is fairly thin compared to the likes of Earth and Venus. Due to this, Mars does not have much protection against meteorite impacts. The temperature on the surface tends to vary from 293 Kelvin to 120 Kelvin, depending on whether or not that side is facing the Sun. Mars has two small moons named Phobos and Deimos, and are named after the horses that pull the chariot of the Greek god of war, Ares. A topic of great discussion is the potential of finding life on Mars. It is currently believed that for life to exist, a few criteria must be met. Bear in mind, however, that there is no one definition of life universally agreed upon, but things we consider to be alive do have things in common. Living organisms all need to respond to their environment, grow and adapt, reproduce, take in energy, have a metabolism, maintain homeostasis and pass on traits to their offspring. Of course, being alive does not mean something walking around on two legs like a human. Bacteria, for example, meet all of the aforementioned criteria, and so can be considered to be alive. Whilst it is unlikely for life to exist on Mars now, scientists are looking into the planet's past to determine whether things like flowing water ever existed. Meteorite samples from the planet can also be examined to see if there are fossilized remains of organisms, such as bacteria. Whilst currently there is no concrete evidence supporting life on Mars, the search continues. In the current history of Martian exploration, only probes, landers, rovers and a single helicopter have had the chance to survey the planet. Recent years, however, there has been a lot of talk of sending humans to Mars. It is only recently that traction has been regained for sending humans back to the Moon, so whilst Mars may be a way off yet, current organisations such as SpaceX have spoken in the past about the challenges of sending humans to the Red Planet, and finding ways around those challenges. This concludes part 1 of the tour of the solar system. We've had a chance to look at the inner solar system, including the planets Mercury, Venus, Earth and Mars, as well as a look at comets. In part 2, we'll be looking at the outer solar system, including the Asteroid Belt, Jupiter, Saturn, Uranus and Neptune. We will also be taking a look at the Kyper Belt. Pioneer 10 was the first spacecraft to visit the outer solar system in 1973, and its target was the Jovian system. Since then, we have explored to the furthest reaches of our solar system, from Saturn, Uranus and Jupiter, all the way to the Kyper Belt and beyond. This show, we will be taking a look at the outer solar system, but first we will be taking a look at what separates the inner solar system from the outer solar system, the Asteroid Belt. Located between the planets Mars and Jupiter, the asteroid belt is home to a collection of dust and rocks left over from the formation of the solar system 4.6 billion years ago. The word asteroid is derived from Greek and has the meaning star-like, as when a man named William Herschel was observing them in 1802, he had no idea what he was looking at. Herschel is often given credit as coming up with the term asteroid, however it is believed the word was actually coined by Greek scholar Charles Burney, who came up with the word whilst collaborating with Herschel on a poem about the cosmos. Currently, it is estimated that there are 1.28 million asteroids in the solar system, of which most of these asteroids are located between Mars and Jupiter. They range in size from 530 km in diameter, which is the size of the asteroid Vesta, the largest known in the solar system, to just a few meters across. Asteroids can be classified in three broad categories relating to their composition. The first classification is C-type asteroids, the C standing for chondrite. These are the most common form of asteroid and likely contain clay and silicate rocks. They also have a dark outer appearance and are among the oldest objects in the solar system. The second class of asteroid is S-type, where S stands for stony. These asteroids are made up of mostly silicate material as well as nickel and iron. The final class of asteroid is M-type, where M stands for metallic. These compose primarily of nickel and iron. The difference in composition of these asteroids is related to how far from the Sun they were formed. Some asteroids would have encountered high temperatures after their formation and partially melted, causing the iron to sink to the centre and forcing volcanic lava to the surface. The formation of Jupiter disrupted the formation of new planets in the asteroid belt region by causing the scattering of asteroids. And despite containing millions of objects, due to the vastness of space, the density of the asteroid belt is so low that spacecraft can pass through the region with next to no risk of collision. The fifth planet from the Sun and the largest in the solar system. Jupiter is the second brightest planet in the night sky, second only to Venus. Jupiter perhaps has the grandest origins for its name in the solar system, as it is named for the Romans' most powerful god, the god of the sky and the king of the gods. This planet is also the first one we encounter on this tour, which is primarily made up of gases as opposed to solid material such as metal and rock. Unlike previous planets, Jupiter has a vast network of natural satellites in orbit. As of 2023, it has at least 80 moons that have been discovered, which is a significant increase from the record holder of the inner solar system, Mars, which only has 2 moons. The first 4 moons discovered around Jupiter are known as the Galilean moons and are named Io, Europa, Ganymede, and Callisto, and they were discovered by Galileo Galilei. His discovery of objects which orbited around another object and not perceivably around the Earth had profound impacts for religion and society as a whole in the 1600s. Io is the second smallest and the innermost of the 4 Galilean moons. It has over 400 active volcanoes on its surface, making it the most volcanically active body in the solar system. The moon also has a very thin atmosphere that is made up of mostly sulfur dioxide emitted from its volcanoes. Europa is the smallest and the second innermost of the Galilean moons. It is nearly the same size as Earth's moon and is tidally locked to Jupiter in its orbit, and so spins faster on its axes than it orbits. And due to Europa being water-rich with a warm interior, it is hypothesized that it could be hospitable to life. Ganymede holds the title of being both Jupiter's largest moon, as well as being the largest moon in the solar system. It is so big, in fact, it is larger than the planet Mercury, and had it not been in orbit of Jupiter, would likely be considered a planet. Much like Europa, it is suspected Ganymede has a subsurface ocean, in addition to having a liquid iron and nickel core, making the moon the only one in the solar system to have a substantial magnetosphere. Callisto is the second largest moon in orbit of Jupiter and is almost the size of Mercury. It is also the most distant of the 4 Galilean moons from Jupiter. The most prominent feature on the surface of Callisto is a multi-ringed impact basin called Valhalla. It stretches across more than 1800 kilometers and was created during an impact around 2 billion to 4 billion years ago. It is also the most heavily cratered body in the solar system, and its surface is layered, with a rigid outer surface and an interior ocean likely made of water, along with salts or possibly ammonia. Jupiter began its formation around 4.5 billion years ago when gravity attracted gas and dust to a singular point, which eventually became what we know as the planet Jupiter. The planet acquired most of the leftover mass from the formation of the Sun, and so has twice the combined mass of all the other planets in the solar system. Jupiter has the same material as many other stars. However, the gas giant did not grow large enough to undergo nuclear fusion. Jupiter actually has a very thin ring system, as do Neptune and Uranus. And the Great Red Spot is a massive storm on Jupiter which has been raging for over 350 years. The storm is so large that 3 Earths could fit inside it. The next celestial object we will be taking a look at is Saturn, the 6th planet from the Sun. The Romans once again lend one of their gods to the naming of this planet, and is named after Saturn, the god of plenty, agriculture and time. Saturn, much like Jupiter, is made up of gases instead of rock and metal, and is host to one of the most beautiful sights to behold through a back garden telescope, the rings of Saturn. It is also host to over 124 moons. Since Saturn has such a large pool of moons to choose from, it may come as no surprise to learn that some of these moons have gathered great interest from the likes of NASA and the ESA. Such moons include Titan and Enceladus. Titan is Saturn's largest moon and the second largest moon in the solar system, as well as being perhaps the most interesting natural satellite within our planetary neighbourhood. It is the only one to be host to a truly substantial atmosphere, and it has an assortment of liquid flowing rivers, lakes and seas of methane and ethane on its surface. Its atmosphere is mainly composed of nitrogen, however its surface pressure is around 50% greater than on Earth. Titan has a thick crust of water ice, however beneath is an ocean primarily composed of liquid water, the very same stuff we find when we go to the beach. It is suspected due to this that beneath the crust could be life as we know it, or life as we are yet to know it. Enceladus is another moon of Saturn's that is host to a liquid water ocean beneath its surface. However, this moon shoots the liquid from beneath its surface out into space, where spacecraft are able to take samples of the ejected material. It has been determined that Enceladus has most of the chemical ingredients for the creation of life as we know it. When the Voyager spacecraft passed by Saturn and its moons, pictures from these craft indicated that despite the small size of Enceladus, it is incredibly smooth in some places and bright white all over. It is the most reflective body in the solar system, and because of this, it has a surface temperature of 72 Kelvin. The main attraction of the planet Saturn is its astonishing ring system. This huge and complex structure is so large that from edge to edge, it would be unable to fit in between the Earth and the Moon. There are 7 main rings, A through E, and are listed in the order in which they were discovered. However, from the planet outward they are listed as D, C, B, A, F, G and E. The main rings of Saturn are the A, B and C rings. The outermost of these is the A ring, which is the most easily visible from back garden telescopes. There is a region of space known as the Cassini division, and it separates the A ring from the B ring. The F ring is located just outside the A ring and is extremely narrow. It is accompanied by 2 very small moons, Pandora and Prometheus. Past the F ring is the much fainter G and E rings. The diffuse E ring expands from the moon Mimas to Titan, which is about 1 million kilometers. Finally, the D ring is the closest ring to Saturn and is extremely faint. Saturn formed around 4.5 billion years ago along with the rest of the solar system, when, like Jupiter, gas and dust was attracted to one point and resulted in the formation of this gas giant. And then, approximately 4 billion years ago, Saturn entered into its current orbit and position in the outer solar system. It is also made up of hydrogen and helium, once again much like Jupiter and the Sun. We now approach the 7th outermost planet in the solar system, Uranus. This planet perhaps has one of the most strangest origins for its name. The name we know it as today is named for the Greek god of the sky. However, when it was directly observed by William Herschel in 1781, he named it after the monarch of Great Britain, King George III, and so the planet was named Georgium Sidus. For better or for worse for patriotic Britons, around 70 years after the planet's observation, it was renamed to Uranus, the name of which was suggested by Johann Bode many years prior. Bode assisted in getting Uranus accepted as a planet because of his own observations 2 years after Herschel's. Unlike Jupiter and Saturn, Uranus has substantially fewer moons, hosting 27 natural satellites, which is still more than any in the inner solar system. The moons of Uranus are not named for Greek or Roman gods like most of the other moons in the solar system. Instead, they are named after characters from the works of William Shakespeare and Alexander Pope. Uranus's inner moons appear to be approximately half water ice and half rock. However, the composition of the outer moons remains unknown, but are likely captured asteroids. Like all the other planets, Uranus formed 4.5 billion years ago, and is one of 2 ice giants in our solar system. 80% of the planet's mass is made up of a hot, dense fluid of icy materials, water, methane, and ammonia, which is located above a small rocky core. Uranus gets its blue-green colour from the methane gas in its atmosphere. Sunlight passes through the atmosphere and is reflected back by Uranus's cloud tops. The methane absorbs the red portion of the sunlight and so leaves the blue-green colour. As mentioned previously when taking a look at Jupiter, Uranus also has rings surrounding it. 2 sets in fact. The eighth and final main planet on this tour is the planet Neptune. The planet was discovered in 1846 by a German astronomer named Johann Gottfried Galle, based on the predictions of French astronomer Urbain Le Verrier. There was some back and forth for a short time between various astronomers and institutions about what this planet should be called, but on December 29th of 1846, a German-Russian astronomer called Friedrich Georg Wilhelm von Struve supported the name Neptune, and so the international community swiftly adopted this name. Neptune is the Roman god of the sea and is akin to Poseidon in Greek mythology. Neptune has 14 known moons, its largest of which is Triton, which was in fact discovered merely 17 days after the discovery of the planet. Its various moons are named after lesser Greek gods of the sea due to the naming of Neptune itself. Triton is the only large moon within the solar system that orbits its host planet in the opposite direction to the planet's rotation. Once again, Neptune was formed 4.5 billion years ago and is made up of the same material as Uranus, a dense fluid-like icy assortment of materials made of water, methane and ammonia. Of all the gas giants in our solar system, Neptune is the densest of them all. Surrounding the planet is a faint ring system which consists of 5 main rings and 4 prominent ring arcs that have been discovered so far. From the innermost ring to the outermost, the rings are named Galle, Le Verrier, La Salle, Arago and Adams. The final region of space we will be taking a look at on this tour is called the Kyper Belt. The name comes from Gerard Kuiper, who published a paper in 1951 that speculated about objects beyond what was at the time the planet Pluto. The region is also sometimes referred to as the Trans-Neptunian region. The belt encompasses a huge volume within the solar system. Within the Kuiper Belt lies many objects: dust, asteroids, comets and dwarf planets. Objects in the belt tend to be extremely influenced by the planets Neptune and Jupiter. These objects that are under the influence of these planets tend to be on a journey that will either see them flung out of our solar system into interstellar space, or will be slammed into the Sun or one of the inner planets. This process takes millions upon millions of years to take place, however. Undoubtedly the most famous Kuiper Belt object is the dwarf planet Pluto. Discovered in 1930, it was the first object to be discovered within the Kuiper Belt. After further observations in that region of space, however, the then planet was reclassified to a dwarf planet in 2006 by a committee in Prague, which redefined the parameters of what it means to be a planet. Pluto met 2 of the 3 requirements. The one it did not meet was the requirement to clear its surrounding neighbourhood of other large objects and the obtaining of gravitational dominance in the region. Pluto has 5 known moons, Charon of which is its largest. It is believed that the objects within the Kuiper Belt are remnants left over from the formation of the solar system. Much like the Asteroid Belt, it is a region of space where a planet may have formed had Neptune not been there. However, due to the planet's gravity causing havoc in the region, the small objects that would have come together to form a planet were simply unable to do so. The Kuiper Belt is donut-shaped and resides around 30 AU from the Sun, and the main region of the belt ends approximately 50 AU from the Sun. The second region, known as the scattered disk, continues outward to around 1000 AU, and even still there are some objects on orbital paths that go out past this point. On this journey, we have travelled over 5.9 billion kilometres, all the way from the centre of the solar system to the farthest reaches of the Kyper Belt, from cratered and barren Mercury to the angelic rings of Saturn. What you have seen only scratches the surface of what there is to explore in our solar system, and is merely a drop in the ocean for what there is to discover in the rest of our galaxy.